Many business cases analyze events that are not equally likely. Some products are more popular than others, and your website gets more visitors in certain parts of the day and less in others. In this movie, I will show you how to generate random values when all of the events are equally likely, such as in a random drawing. This is called the uniform distribution. And if there are 4 possible outcomes, values 1 through 4, then in the uniform distribution, the probability of each would be 25%. Now, over time, it is very unlikely that you will have the same number of values exactly. However, they will be close. And here is one case where I did a random generation of numbers from 1 to 4, and here you see the actual results. So, as with most things in life, theory and practice are often close, but do diverge. Now let's switch over to Excel, and I will show you how to work with values that are uniformly distributed. The Excel workbook that I'm using is 0402 Uniform, and you can find it in the Chapter 4 folder of the Exercise Files collection. And for this, I have laid out a spreadsheet, and I will perform a number of calculations. Let's say that I want to have a minimum value of 1, so I'll type that in cell B3, then enter, and a maximum value of 6. So type 6 and enter. And our number of values I know is 6, but if I want to calculate it, I can do equal B4 minus B3 plus 1. And that's because I am subtracting the value in B3, which in this case is 1, so I need to add 1 back, otherwise I would get 5. So I'll press enter and enter again to move down to cell B7. If I want to generate a random number, that is a random whole number or integer between 1 and 6, then I can use the function randBetween. In B7, I will type equal, and then the function is randBetween, and the bottom value is in B3, comma, top value in B4, right parentheses and enter, and I get the value of 3. Now for value 2, I will do the same thing. So I'll do equal, randBetween. Excuse me, I started typing in the numbers directly, but it's better to use a cell reference so you can change the values without having to edit a formula. So that's B3 for the bottom value, and then comma, top values in B4, right parentheses and enter. And my worksheet recalculated so I have both 4 and 3. Now I can calculate the probability of getting value 1. So I will go over to cell E3. And here, because I know that I have a uniform distribution, that every value is equally likely. So I will, in cell E3, type an equal sign, then 1, because I'm only looking for 1 value, and divide that by the number of values, which is in cell B5. Enter. And I get a probability of 0.166 repeating. So 1/6 of the time, which matches our 6 possible values. If I want to calculate the probability of value 1 or value 2, then that would be equal 1 divided by the number of values, which again is in B5, plus 1 divided by B5 again, because I'm looking at 2 distinct values. Enter, and I get 0.33. And yes, it is possible that the randomly generated values in cells B7 and B8 could be the same, in which case the probability of value 1 or value 2 would be the same as getting a single value, but I'm working in the abstract here as opposed to with the specific values in B7 and B8. If you want to calculate the probability of getting neither value 1 or value 2, then you would subtract the probability of the positive outcome from 1. So in cell E7, I'll type equal, and it'll be 1 minus the value in E5. Enter, and we get 0.666 repeating. So about 2/3 of the time, which makes sense. 4 out of 6 times, you will not get 1 of 2 values, distinct values, and that will happen about 2/3 of the time, so our value is correct. And I have saved cell B10 for last because I want to show you another way to generate random numbers between 0 and 1. And this is a 16-digit decimal. So in B10, I'll type equal, and then rand, followed by an open and close parentheses. And this value will be a random number, a decimal number between 0 and 1. So enter, and there we get 0.81534. And the number is actually larger than that. So if I click cell B10 and go to the Home tab and click Increase Decimal, you can see that the value increases. So what is the probability of generating this specific value? It is effectively 0. There are so many decimal points here, and I'm just estimating. Let's say there are 12 digits there. If we look at 12 digits or 13, that would be in the billions. So the probability of getting exactly this value is extremely low. And if I press F9 to recalculate, I get a different value. And again, and the probability of those values repeating is so small, it's not worth worrying about. So I hope that this movie has given you an introduction to working with random numbers, both as integers and as decimal values between 0 and 1.